Amy's academic background is in polymer chemistry and mathematics, while her professional background is in the electronics industry. Amy has worked in a variety of engineering roles, including mechanical and electromechanical, and spent 1 year on a Fulbright grant studying the cost effects of lead-free manufacturing. Amy transitioned from engineering roles into technical sales and account management in late 2010, and thinks that her experience living abroad and working with multiple global corporations has provided her with an international view of the electronics industry. Amy's work with cost comparisons of panel-level and wafer-level fan-out packaging processes has been outstanding and of great value to our industry. Let's join Amy Lujan, President of Savansis Solutions LLC and General Chair-elect 2025 for the International Microelectronics Assembly and Packaging Society, to discuss understanding the cost of fan-out wafer-level packaging.
All right, so very brief introduction. The course, really what I'm trying to do here is talk about fan-out-wafer-level packaging. What are the cost drivers? What are some actual costs? I want you to walk away from this not necessarily an expert on fan-out, but having a really good grasp of where the costs come from. I'll spend a little bit of time introducing the type of cost modeling that I use. Then I will jump into the technology, the process flows, dig into a cost breakdown of the different activities, and then get into some case studies. Typically what happens, especially for your chip first styles, is you're placing your die and then you're applying mold. So once you've applied the mold application causes your die to move around. Or if the mold application doesn't do it, once you're curing your mold, there can be warpage. So there's this thing that happens where the die are not quite where you think they're supposed to be. When that happens, some of the types of fan-out fare better than others. So in chip first face up, that's where you suffer the most from this potential for defects, because you placed your die face down, you applied your mold, and your die is shifted. So you flip it over and you build your RDLs, and you really hope your die are exactly where you think they're going to be. So it's a 5x5 die and a 10x10 package. And I have all the same costs that exist for both of them, and some of the costs that are now standalone. This is a 15x15 substrate for our advanced fan-out package to go onto. So what I will tell you is that I cut the grat off because our substrate cost really dominates when you're comparing it to all these smaller broken up chunks of the process. So that was not to scale, it's off the chart. But what I want to just focus on right now is the costs that are different or might have changed.